I am a huge soccer fan, have been for my entire life. I have fond memories of playing the game while growing up, excluding the 1 or 2 times I got kicked in the face with the ball directly off the kickoff. But even to this day, I still get a rush of adrenaline every time the whistle blows, whether it's a game I'm playing in or not. Over the years, you could say I've learned the primitives of the game: passing, shooting, dribbling, defending, doing skill moves. Each concept is not very useful on its own, but piece them together and you've got a player's skill set. In a similar way, security for your Firebase app is composed of a bunch of different primitives or core concepts that individually don't do much, but when you compose them together, you can form very powerful rules and protect your data even for complex applications. And today, I'm going to be your coach, so to speak, and I'll train you on these concepts. And if you haven't already guessed it, I'll be using the help of the sport that I love. My name is Jacob Wenger, and I've been on the Firebase team for over 2 years now, back since its startup days. So you could say I've become a bit of an expert on the real-time database. I'm hoping to share that knowledge with you today. And I know it's early, and I know I'm talking about security, a traditionally boring subject, so I thought I'd spice it up a little bit. And instead of just talking about the key to Firebase security, we'll talk about the key to Firebase security as told with emojis. So you'll be seeing a lot of that over the next half hour. Yesterday, you heard all about the next generation of Firebase and how Firebase is now a lot more than just a real-time database. It is a suite of integrated products to help you develop your app, grow your user base, and earn money. Today, I'm going to bridge the gap a little bit between the old and the new world and talk to you about security in your Firebase apps across 2 different products. The first is the Firebase real-time database. This is the old, reliable, battle-tested real-time database that excels at syncing arbitrary JSON data, such as a team schedule or the league standings. The second product is the brand shiny new Firebase storage. You'll use this to store files like video highlights from last night's match, or an audio clip of an announcer, a Spanish announcer screaming, "Goal!" I do not know how they hold that for so long. I definitely could not do it. Thank you. Thank you. In order to explain Firebase security, I first need to tell you about what exactly do I mean by security. The way I actually see it is that there are 2 sides of the security coin. On the one side, you have authentication, and on the other side, you have authorization. What exactly do these terms mean? Authentication is the process of verifying users are who they actually say they are. So this user is Sarah, and this user is Billy. Authorization, on the other hand, is the process of determining who has access to what data. So maybe Sarah has a ticket to the match and is going to be able to get in, whereas Billy is empty-handed and is going to be stuck watching the game from the pub. Traditionally, implementing both sides of the authentication, both sides of security, took a lot of work. You had to manage your own servers, you had to set up your own databases, and you had to write a bunch of custom server-side code to actually protect your users. Thankfully, Firebase makes this really simple because we have products that do this out of the box. On the authentication side, we have a product called Firebase Authentication. Very original, I know. But Firebase Authentication allows you to verify your users in a bunch of different ways. We have anonymous verification, which allows you to assign a random UID, a unique identifier, to every user. We have email password authentication, which allows you to verify a user using a combination of email and password. Then there's OAuth authentication, which uses a third-party provider, like Facebook or Google, to verify users on your behalf, saving you a ton of time and a ton of anguish. Finally, there's custom authentication, when you need something a little extra or custom, or you need to integrate with an existing auth solution. I won't be focusing very much on Firebase authentication during this talk today, but if you're interested in it, tomorrow at 1 p.m. on this stage, there's a talk called Best Practices for a Great Sign-In Experience. And so if you want to learn more about the Firebase Auth product, definitely go and check that out. What I will be focusing on today, though, is authorization. And the way we do authorization in Firebase is we use what we call Firebase rules for both the real-time database and for Firebase storage. I think the best way to learn this stuff is to actually go through a ton of different examples. And we're going to start with learning the primitives of the Firebase real-time database rules language. Before we can actually protect data, we need to know what data we're going to protect. So kicking things off, we'll start with some example data for a real-time database. The real-time database stores JSON data. So here we have an empty JSON object so far. We can go ahead and say, let's put a top-level games node. And this is where we're going to store all of the game information, including the schedule for the current team. Within the games node, we're going to have a bunch of random IDs, which we call push IDs in the Firebase real-time database. And these are going to uniquely identify every game in our list. So within each game, we'll have a bunch of different content about that game. We'll have the date of the game, who the opponent is, and whether or not the game is open to the public. There'll also be a game content node. And this is the data that we actually want to protect to ticketed customers only. So people who actually have bought ticket to the game should be able to see stuff in game content. Lastly, we'll have a tickets node. And this is just going to be a list of users who have tickets to the current game. So the best place to start with security is with what the defaults are. Traditionally, our default rules looked a little bit like this. Just like the data you store in your real-time database, your rules are also a JSON object. It always has a top-level rules node. And then within that, by default, we have read true, write true. So this is the first primitive that we're going to learn, is .read and .write. .read determines who has read access, and .write determines who has write access. So as I'm sure you can tell from this, this means everyone and anyone has access to all of your data, both to read it and to write it. This is pretty great for getting started because you can go ahead and create a new Firebase database and then start writing and reading from it right away. But it also allows people like this guy, a malicious attacker, to steal all of your data. How would they do that? They can easily circumvent them by writing just a few lines of code. So this is using the brand new Firebase 3.0 SDK. And what we're going to do, for those who are familiar with the real-time database, you used to do new Firebase and pass your database URL. Now you're going to go ahead and call firebase.initializeApp. You pass your API key, an auth domain to do authentication, and the database URL, which is where you're going to store your data. Once you have an instance of an app, you can get a database instance and then call .ref on that. And that's actually going to give you a reference, a pointer to your data stored in your Firebase real-time database. We won't actually pull any data down yet, but we can go ahead and do that by doing a once value. This essentially is going to do a get on our data. This will return a promise fulfilled with the snapshot of that data. This is an immutable snapshot, and we can extract the data from that by calling .val on the snapshot. And now I have taken all of your data. So this is definitely not great. So as of yesterday, we've actually updated what our default rules are when you create a new Firebase real-time database. So we still have the rules node. And instead of read true, write true, we're going to see auth does not equal null for both of those. So this is the next concept, this auth variable. This is a top-level variable populated by the rules language itself. And it represents the authentication state of the client making the request. So if I'm making a request from a laptop that is not authenticated with Firebase, this auth variable will be null, and I will not be able to read or write any data. If I'm making it from a phone that is authenticated with Facebook, the auth variable will not be null, and it'll actually contain a UID, which is a unique identifier for that user. Every time that specific user signs in via Facebook, they will be given the same UID. And if I'm authenticated, I'll go ahead and be able to read. So this is better because by default, no authentication providers are enabled for your Firebase database when you create it. So by default, no one can read or write data, and you actually need to add authentication. So let's say you want to add anonymous authentication, which is a common use case for many apps. And now a guy who can see these rules says, hey, you know, I can work with this because they're still a bit too open. Let's look at some code again. We'll initialize the app in the same exact way. And now we'll just call auth.signin anonymously. So now we will be authenticated, and any request we make from this client will have a non-null auth variable in the rules. So we go ahead, and after that promise is fulfilled, we will get a reference to our root of our database. We will this time remove all of the data, and then we'll log that the data was removed. So this is kind of terrifying and not what we want by the time we release our application to production. So I know exactly what you're thinking. You're saying, this is really easy, Jacob. Like, all you need to do is lock this thing down. And so we can go ahead and do that. We can say, let's go ahead and just say no one can read and no one can write anything at all. 100 points. My app is entirely secure. No one is going to be touching any of my data. And this is very true, but it also kind of renders your app pointless. Kind of like the face massage emoji, which I legitimately have never had a reason to use before. I guess until today. Before I move on beyond this obviously pointless rule set, I want to introduce an important concept. And that is that in the rules language, doing read and write false is equivalent to not putting those rules at all. And the default value is actually false. So this is kind of a contrived example, but these two rule sets are actually the same. And this will come into play in some of our later examples. So we don't want to just not allow anyone to read or write. So let's say we'll grant public access to all of the games node. How can we actually do that? We'll go ahead and create a games node within our rules, and then we'll just say read true. So now everyone can read all of the different games and see the entire schedule. This is not exactly what we want, because we know that some games we want to have only ticketed customers or only people who are authenticated. And in other games, we allow them to be public. So we can go ahead and make a semi-public schedule by, instead of just doing read true, actually specifying the game ID for every single game. And for the top game, we know the isPublic flag is set to true, so we'll just put read true. And for the other game, we know that it's not public, so we need to be authenticated. So this works, although it has a couple issues. The first is that this read true rule is hard-coded. And the only reason we put it read true is because we know the data we started with, the isPublic field, was actually set to true. But what we want to look at is we actually want to look at that isPublic field itself and use that existing data to determine our rule. Thankfully, we can go ahead and do this by changing both of these rules to the same rule. And the rule is going to say, am I authenticated, or is the isPublic field set to true? So we start with our auth does not equal null. And then we say, we use this data variable. And this is another top-level variable, like auth, which represents the existing data in your Firebase real-time database. So we say, at the current location, which is games / that long UID, is the isPublic child set, and is its value true? If so, allow anyone to read this node. So this is getting us closer, but we still have another problem. These game IDs are randomly generated push IDs, and we actually won't know what they are before our app is sent to production. So we can't hard code them into our rules. And also, we don't want to have to specify the same rule over and over for all these different games. So we can go ahead and get rid of all of that and replace them with what we call wildcard locations. That's what this dollar represents. So $game_ID is a wildcard character, kind of like a variable, that will match all strings. So it'll match all of those game IDs that we previously saw. And now, instead of specifying this rule that we saw earlier for every single game, we only need to specify it one time. So this is good, except for the fact that the data we store in the games node is actually we want different access levels for different pieces of data. For this top field, the date, the opponent, and the isPublic flags, that should always be publicly readable by everybody. There's no reason that people shouldn't be able to look at the date, the opponent, and the isPublic flag. Whereas the game content, we know we only want ticketed customers to actually be able to see this, or see it if it is public. And then finally, the tickets node, we're probably going to want to lock down on a per user basis, where I can go ahead and buy a ticket myself, or I can remove my ticket, but a random person can't write to my ticket node. So if we look at how to do this with the rules, let's just put a read rule on our game. And then underneath that, we'll say, you can only read the game content given that rule we determined earlier. And then for tickets, we do want to do it on a per user basis. But for now, we'll just say, do you have a ticket? If so, you can read all tickets. So this seems like it would work, except it actually won't. And that's because of what we call the rules cascade, which is another one of our core concepts of the rules language. The rules cascade essentially says that in order to read data at A/B/C, you just need a read rule that evaluates to true at any level in that parent hierarchy. So in order to read the data at games, game ID, game content, we actually would start at the top and look at the games node, and we would say, do we have a read rule here? And we don't, but we know that that just implies that we have a read false. And so we know that the read won't be allowed at that level because we don't have a read true. So then we move down to the next level in the parent hierarchy, and we go to game ID. Game ID does have a read rule, which evaluates to read true, and so the read will be allowed. And so we actually will completely ignore this game content read rule. And that's because if we are allowing people to read games/game ID, then they certainly are going to be able to read games/game ID/game content. So in addition, this tickets rule won't even be included either. So we need to work around this a little bit. And the way we can do that is, one option is just copying these two rules that we had previously, and then just specifying read true for every field we want to be publicly readable. This definitely works, but it involves a bunch of different read rules. And now every time we want to add another public field, we're going to have to add it to our rules. So if we want to add a time to let people know when the time of the game is, we now need to add a rule, which is time read true. So we can actually get around this by restructuring our data a little bit. Instead of putting date, opponent, and isPublic at the top level of the game, we can get rid of it, add a new metadata node, and then throw those things in the metadata node. And we can go ahead and refactor our rules in a very similar way. Get rid of those three rules, replace them with a single metadata rule, which is read true. And now our rules are simpler. We have fewer of them. And if we ever want to add that time node, we don't have to do anything with our rules. We can just add it to metadata, and it will be publicly accessible. So we're getting close. The next thing we want to talk about is this rule right here. So currently we're allowing people to read the game content node if they're authenticated at all. And in our soccer example, this essentially would be, I have a ticket. But I have a ticket to some game, not I have a ticket to this game. So we actually want to lock it down to only people who have tickets to this game, not just a ticket in general. So in order to do that, let's take a look at what our tickets node looks like. We're going to have it keyed by unique identifiers. These are those UIDs I was talking about earlier when user authenticates. So it's a long, you can assume it's a random string. And we're going to go ahead and create a hash map of those UIDs. And so we can go ahead and change our rules now and say our tickets node is going to be keyed by UID. So we'll use a wildcard location to match all of those random strings. And we're going to go ahead and say read and write if auth.uid triple equals $UID. So let's break this down a little bit. We know the auth variable has our user's authentication state, so it's the currently logged in user. And if their UID is the same as the location we're writing to, which is that $UID, we'll allow them to write to that node and read from it. This is what we call user-based security. So we've locked down the tickets node. The next thing we want to do is lock down this game content node. And essentially what we want to say is if the tickets node has the currently logged in user's UID as a key, then go ahead and allow the write or allow the read. We can do that by using a parent reference. So we take data, which again is the current data at that location. We call parent. Then we go to the tickets node. We see if it has the currently logged in user as a child. So the last thing in this example I want to talk through is actually being able to edit the schedule itself. Here we can add an admins node at the same level as our games node in our data structure. And we'll key it again by UID of all of the admins of the app. And then you can throw a bunch of profile information. For here, I'm just going to put the name. So we want to lock down that metadata node, which actually determines the schedule, so that only admins can write to it. The way we can do that is by using this root reference. So we say root, which is going to take us to the root of our Firebase. We go to the admin's child, and we see if the currently logged in user is in that node. So that works. We've now locked down our data so that the people who should be able to read it can read it, and the people who should be able to write it can write it. But we need to validate that the write is actually correct. Because you could write wrong data, write a date that is not a date at all. But that's not really what we want. So we copy our rules from the previous slide. And then we say, let's add rules to date and opponent, which say the new data must be a string. So what's going on here? We are referencing the new data that we're about to be written. Whereas data talks about the data that's currently stored before the write, new data is going to be the data that's about to be written to that node. So we want to say, when we write a date and an opponent, it must be a string. So this seems like it should work. But again, we're going to run into issues with our rules cascade. Because just like the read rules, the write rules follow the rules cascade. So in this example, let's say we try and write a number to metadata/date as an authenticated admin. We would first touch that top rule, which says, are you an admin? And it would say, yes, I am. And at that point, this date rule would be completely ignored. This is not what we want. So we can go ahead and also look at it the other direction. Let's say we want to write a string, but we are not an admin. We first would go to that top write rule. We'd say, are you an admin? It would say, nope, not an admin. So then we'd go down to the next write rule, which says, are you writing a string? We'd say, yeah, I'm writing a string. And we would allow that write to happen, completely ignoring this admin rule, which is definitely not what we want, because we want to lock down writes to admins. So how can we solve this? It's actually really simple. All we need to do is change these write rules to what we call validate rules. Validate rules are different than read and write rules. And the way I like to think about it is that in order for a write to succeed, all you need is one write rule in that hierarchy to be true. So all of the write rules are ORed together. If any one is true, then the write will succeed. Whereas with validate rules, you need all validate rules to be true. So validate rules are ANDed together. So with validation, you can actually do some pretty complex stuff. So taking our previous example, we can actually require nodes. So we can say the new data that we're about to write to metadata must have a date and must have an opponent. We can also say more complex things than just, is it a string? We can use regular expressions to verify that the date has the proper format. We can use contains queries, this is kind of an arbitrary example, but we can say the opponent must contain an S in their name. We can say more things like, is this a Boolean or is this a number? And then one trick I really like is this $other field. This is kind of a little trick which says, don't allow any other nodes to be written to this field. So $other will match all other strings that aren't date, opponent, and is public. And we're just going to put validate false, which means if those are there, just completely fail the write. So these are really just a few examples of what you can do with our validation rules. You can actually combine them in a bunch of different ways and do some pretty complex schema validation, including implementing things like counters, time expiring data, and even user rate limiting. So we've seen a bunch of different examples of how to actually do security rules. But I'm going to head over to my laptop. And there's one thing to actually see code on slide, and it's completely another to actually play with it. So I'll come over here. And this is the brand new Firebase dashboard. How many people have already played around with this thing? All right, cool. A little over half the group. So it looks a lot more beautiful than our old dashboard. Over here on the left, you can see all of the products that are now a part of Firebase. And we're going to be playing with database. So we'll head over to the database data viewer. And that's what we see right away. We see all of the data that's currently stored in our Firebase database. I've already prepared some example data. And I will go ahead and load that. And it's going to have the same format as all of the examples we've been playing with. So we have a bunch of different admins, which are keyed by UID and include the name of the admin. And then we have a bunch of different games, which include game content, which we're going to lock down to ticketed customers. We have our metadata, which includes our isPublic field, and our tickets, which again is keyed by UID. So we can actually play with these rules by going to the rules simulator. And so the first thing we're going to want to do is click this little button over here. And that's actually going to open up our simulator. So by default, again, our rules are you just need to be authenticated to write or to read. So the first thing we can do is just say, hey, I'm going to try and read from /games, even though I'm not authenticated. and we'll see that the simulated read was denied. And cool thing is you can actually come in here and see which rule caused the failure. So we see on line 3, a little arrow pops up that says the read was denied here. So we can go ahead and we know we can work around this. We can say, let's just put games.read is going to be true. And we go ahead and run this again. And we can see our rules cascade at work. So we're going to start by this top rule. The read is not going to be allowed. But then we'll head down to this rule on line 6, and we'll see that the read is actually going to be allowed. And because read rules are ORed together, the write overall will be allowed. And then if we look at just reading from the root again, we'll see that, again, we're not going to be able to do anything. So we can go ahead and see this a little bit more if we swap the read rules here. So if we say, put our read rule at the top, move this read rule down here within games, and then try and read from /games again, we'll see our rules cascade where we hit that read rule at the top, and we don't even need to check the second read rule because it's already going to be allowed. And similarly, when we just read at root, it's also going to be allowed. So let's go ahead and add the rules that we came up with during our slides and copy them here. This is exactly the full set that we talked through. And we have our rules for the metadata node, for the game content node, and for the ticket node. So we'll go ahead and publish these rules, which is actually going to upload those to Firebase servers and put them live in your app. And then we're going to try doing some writes. The first thing we'll do is we will write to games. And then we're going to want to grab one of our game IDs. So we'll head over here and just grab this first game ID. And head back to write. Games/that game ID/metadata. And what we're going to want to write is we'll start with just foo. So we click run, and we see that we're not going to pass because we're not actually authenticated. So this auth variable is not even set. So let's go ahead and authenticate. Here you can see the authenticated section where we can choose a bunch of different providers that we want to pretend to authenticate with. And we can actually override the UID that we use in the authentication. For now, we'll just use the randomly assigned UID. And we'll click run. And we'll see that, oh man, we still failed the same rule. Even though we have an auth.uid now, but we're not actually an admin. So we head back over to the admin section. We grab the admin UID. And we throw it in here. And now we run. And all right, so we passed the rule on line 8, but now we're failing one of our validate rules. It says new data must have date and opponent. OK, we can work with that. We'll go ahead and change this to have a date, which will be tomorrow. And we're going to intentionally have a mistake in there where we only put 3 characters for the year. And then for the opponent, we'll go ahead and say we're going to be playing Arsenal tomorrow. If we run that, we'll see we now pass the first validate rule, but that still doesn't allow the write to happen. We fail this regular expression. So we can fix that by making that 2016, click run, and now we see all of the different rules succeed, and our overall simulated write was allowed. You can also go to this details section to get a ton more details about why the write was allowed. You can see the type, where it was written to, what data, what authentication state was, whether or not you were an admin, and then a bunch of different data for each line that was executed in the write. So if we head back over to the slides, you've kind of gotten a whirlwind tour so far of both the rules language itself and the actual simulator. So if we head back over to the slides, hopefully you guys are not feeling too overwhelmed at this point. And hopefully you're realizing the breadth of security, the options that you have available to you. But I kind of realized that a lot of you, I've gone through a bunch of stuff already, and you may be feeling a bit stressed, or you may be feeling more scared, or you may even possibly be feeling like this and be completely lost. And we realize that. Security is not easy. There's no getting around that. Firebase has also taken a different approach to security than many of you are familiar with. So in fact, we found that security rules were consistently one of the hardest things for new Firebase developers to figure out. So we heard that feedback, and we actually were playing around with improving this situation by creating what we called rules compilers. So first came a compiler called Blaze, which introduced some stuff like types and functions and inline tests. And then came Bolt, which built on the work of Blaze and also included types, including generic types. It included a cleaner syntax to write less code, and it also included match paths to make your rules easier to read and write. But there was still a problem. And the problem was that all of our rules, languages, and compilers were all very database specific. And now Firebase is much more than a real-time database. It's now an integrated suite of products. And that's kind of where this next product comes in, Firebase Storage. We needed a rules language for Firebase Storage, and we felt like the existing rules language just left a little bit too much to be desired. So we kind of went back to the drawing board, and we built a new rules language from the ground up. One that borrowed heavily from the real-time database rules, the things that we liked from that and that our users were able to pick up very quickly, and also included the different learnings that we got from our Blaze and Bolt compilers. So it's still early days for the Firebase storage. There's lots of stuff that we still have planned and that is still going to be coming out. But I do want to give you a walkthrough of the existing features and show you how you can use it to protect your files stored in Firebase storage. Again, before we actually look at any data, before we look at any rules, we need to look at the data we're going to be protecting. We already know the real-time database stores data like this. We have a users node. We have it keyed by UID, and we have a bunch of profile information. This is JSON data. Firebase storage, on the other hand, is going to be protecting data like this. This is a directory structure, like you'd have on your local file system. Instead of a users node, you'd have a users directory. And within that, you'd have a directory for each user. And for each user, you'd have a bunch of different images and audio files, movies, and text files. And this is the kind of stuff that we're going to want to protect. So what do the rules actually look like? The syntax is going to be very different from the real-time database rules, but the concepts are still very much the same. So we start with the default storage rules. And the default rules say, we first are going to specify what service we are using to write rules. So we're going to say we're using the Firebase.storage service. Within that, we need to specify what bucket. This is our Google Cloud Storage bucket we're going to be reading and writing files to. And then we're going to use match paths. And the way to interpret this syntax, is that the curly braces are actually kind of equivalent to the dollar wildcard locations in the real-time database rules. And so what's saying here is we're going to match all paths, a wildcard, all strings, and the equals $$ essentially says allow it to be many levels deep. So by default, if you just had all paths with no equals $$, it would only match one level deep. This will match as far down as we want to go. And within that, we'll go ahead and say allow read and write. You see we have a more compact syntax because we're allowed to do read and write rules on the same line. And we'll say if request.auth is not null, allow the read and write to happen. So these rules are equivalent to the default rules for the real-time database. There are a few differences in the actual conditional. So like auth has moved from a top-level variable into this request variable. And the request is going to contain all of the information about the request that is being made, the read or the write. So let's look at a few more examples. Maybe we don't want to actually do read, write only if you're authenticated. What if we want to make all the stuff public? We can do that by just doing allow read, write with no conditional. Again, much more compact syntax than the database rules. Similarly, to do private, we can go ahead and just add in conditional, which says if false, which will always evaluate to false. So this would not allow anyone to read anything. Finally, we can do user-based security. So instead of doing that all paths match, we're going to go ahead and do a match path which looks like this. We're going to say go to the users directory and then do match any string, which is going to be our UID, the unique identifier for that user, and then match all files. This time we're not using =**, so we're not going to do multi-level match paths. And we'll go ahead and say you're allowed to read and write if you are the currently authenticated user. So we say request.auth.uid equals the UID. And that second UID comes from the match path itself. So let's head to a soccer example. And let's talk about actually storing some game highlights. Like we had in the real-time database, we'll have a top-level games directory instead of a games node. We will again key that directory by the game ID. So the data between the two is actually looking pretty similar, the structure. And then within each game, we'll have a highlight reel. We will have a recording of the audio. And we will have a bunch of different fan images. These fan images will be keyed by the unique identifier of those fans. And within that, we'll have a bunch of different images. So we want to go ahead and write some rules to protect this data. First thing we'll do is we'll write a top-level match path, which says /games/game-id. So this is exactly the kind of thing we did with the rules language, except we're doing it much more compactly. And then we'll nest match paths, like we were able to nest rules in the database rules. And we'll say, if in game/game-id we have a highlights movie, let's go ahead and allow everyone to read it. And let's allow you to write to it if you are authenticated as an admin. And so here we're using a new concept, and this is actually using our custom authentication. So that auth variable that specifies a UID in the rules language, you can actually make any variable within that auth variable. So you can say auth.isAdmin. And so in the storage rules, that data is stored in request.auth.token. And then we store a bunch of custom attributes that we want to write. And in this case, we'll store whether or not the user is an admin. Next, we need to do rules for the recording audio file. And those rules are actually going to be identical to the highlights reel. Finally, we need to protect our user's data. So within fan images UID file name, we will allow all of those to be read. It's a public view. But we'll only allow you to write it if you are that logged in user. So we can go ahead and clean up some of these rules and make these even more compact. The first thing we'll do is we'll notice that the rules for highlight reel and the recording are actually identical. So let's go ahead and get rid of one, slightly change our match path to say just match on any file name, and then update our write rule, from which currently just checks if we're an admin, to also check that the file name itself is either highlights.move or recording.mp3. So we've gotten rid of a bunch of different lines. Next thing we can do is actually extract this read rule from these two rules, because we know that everything is publicly readable. So if we pull that out, we go ahead and squish those two guys down. And then we create a match path for all paths, as many levels deep as we want, and just put in allow read. We've now taken what was initially 6 rules and made it down to 3, which is much easier to read and much easier to understand, less to keep in your head. So one thing you're definitely going to want to do with your files is validate that they are of the correct type and the correct size and things like that. So the validation for the storage language is actually quite different from what we have in the rules language. We start with our rule, which just says you need to be the logged in user. And then we'll go ahead and add a rule which says the size of the resource that we're about to write has to be less than 5 megabytes. We can also do things like check the content type and verify that the content type of the resource we're writing is an image. Even more so, we can actually determine which kind of writes we're going to allow. So we can disable deletes by doing a request.resource does not equal null. And if you think about this, this is saying if I ever try and write a resource to this location that is null, which means that I'm obliterating what is existingly there, then I won't be able to do that. And then finally, we can verify that the file name itself is less than 32 characters. So one of the big things I'm very excited about with storage that we don't have in the database rules language is functions. This is something that people loved from Blaze and the Bolt compilers. So let's go ahead and take a subset of the rules that we had in the last slide and turn them into functions. First, we'll start with, is this the current user? We'll go ahead and create a function called isCurrentUser, which takes a UID. And we will just return that same rule set, verifying that the logged in user is the same as the UID the function takes. And if that is true, we can go ahead and replace this rule down here with a much shorter rule, which is just isCurrentUser and pass the UID. Similarly, we can do the same with the resource.size rule. We'll go ahead and create a less than n megabytes rule or function, pass it the size of the number of megabytes we want to limit to, and then we can replace the rule down here with a call to less than n megabytes, 5. Finally, we can take the rule that checks whether or not the file is an image, create a function called isImage, which just returns the same exact rule, and replace the call down here with isImage. So we've taken what was a pretty long and hard to read write rule and turned it into something which is actually pretty clear and easy to understand. Even if you didn't write these rules yourself, you could read this and understand who is going to have access and what type of files will be written here. It's even short enough that you can fit it all in a single line of code. So this is a huge improvement over the existing rules language, and I think you guys are going to find that it's going to clean up a lot of your code. So that is the new Firebase storage rules language. As with the database rules language, it's composed of a dozen or so primitives, which you can compose together to actually form really complex file access rules and validation. It includes a bunch of things from the database rules language itself, but also all the new improvements that we got from things like Blaze and Bolt. And it is better situated for the new multi-product world that Firebase now occupies. At this point, I think congratulations are in order. You all just made it through my 9 a.m. talk on security. You now know the tools you have at your disposal to protect your Firebase data in both the real-time database and in storage. Hopefully, you use these primitives and put them into either an existing app, or if you're new to Firebase, a brand new app, and make sure you actually are protecting your data. If you're interested in learning more, you can find more in our documentation. Head on over to firebase.google.com. We have documentation for all of the different products. You also can find out about all of the other parts of Firebase, all of the new things that were announced yesterday by heading to our features page. And lastly, support is a huge part of what has made Firebase successful so far, and it's something that we continue to try and strive and do our best at, and that's not going to be changing anytime soon. So please head on over to the support page, join our Slack community, join our Google Groups, join our Stack Overflow community, and be a part of the conversation. Let us know what features you want, whether it's with the rules language, whether it's with the actual database rules or storage, or any other product. We definitely value your feedback, and a lot of what we released yesterday is based on feedback from customers like you. Also, brand new YouTube channel with a bunch of really cool intro videos for all of the new features. And you can always find us on Firebase on Twitter for all of the up-to-date news. There's still a lot of cool stuff happening at I/O. We've still got 2 full days left. Half the office hours are over, but you should definitely check out the one that's at 5 p.m. today, or one of the ones tomorrow. Also, if you're interested in seeing more Firebase sessions, I think there's still double-digit talks left that are just about Firebase. So 2 that you may be interested in if you thought this was a good talk. One would be Zero to App, Develop with Firebase. That's going to be tomorrow at 10 a.m. on the main amphitheater. And this is actually a really cool talk where they're going to be building an Android, an iOS, and a web app, all that communicate with each other, all from scratch, that includes storage, database rules, and authentication, all in 45 minutes. So it's going to be exciting whether or not they're able to do it, so you should definitely check it out. The other talk you may be interested in is the one I mentioned earlier, which is about Firebase authentication. That one is on this stage tomorrow at 1 p.m. Lastly, if you're interested in talking more about Firebase, come join us right over at the sandbox right next door, and we can take a look at one of your existing apps, talk through rules in your app, or talk about any of the new features. So thank you, everyone, for coming this morning and learning about the key to Firebase security. My name's been Jacob Wanger. If you're interested in this kind of information, you can find more on my Twitter at _JWanger. Thank you very much. Peace out, and do not forget to protect your Firebase data.